All right, there we go. We are online and ready to go for the last session of day one of ANZ Coders, and I have decided to bring myself some supplies. I don't know if this is enough. It should do. It's either that or the giant popcorn, you know. So this session we're doing microservices. We have Colin Scott with us to bamboozle us with science. So I'm going to pretty much hand over, as always, straight over. No Game of Thrones spoilers, by the way. Stop it. And Colin, over to you.
Evening all. And has the screen switched over? Cool. Good evening. So tonight's talk is about microservice design patterns in line of business applications. So line of business applications are obviously systems that support business processes, generally characterized by complex business rules and potentially long-running processes that tend not to be real-time. This presentation itself is going to be fairly high level. Got some diagrams, but no code. And in case you don't know me, my name's Colin Scott. I'm a senior developer from Perth, and I frequently say stupid things on Twitter. So, the most important question you have to ask when considering microservices is, should I actually use microservices at all? This is basically the most important. Every talk about microservices should basically start with this question. If you don't get any benefits from microservices, the costs will be very high and unnecessary complexity. So what specifically are the kinds of questions you need to ask? Well, first you need to ask, does my problem actually justify using microservices? Because not every problem will benefit from them. You need to have a complex domain, because simpler domains generally will not decompose into enough components to make managing them separately worthwhile. Microservices make changing pieces in isolation simple. If you don't need to change things that often, then your justification is diminished. And also, just because you want to do microservices doesn't mean that you or your organization actually has the capability of delivering them. A system with many pieces is something that you need to be able to deploy in an automated and repeatable fashion. Human involvement in that should be limited to basically hitting the button that selects the version you want to deploy. It's not feasible to do manual deployment with something that has a large number of pieces. So if you're still stuck with a manual deployment process, you're going to need to invest in significant automation of that process. You'll also need to have a robust testing approach, because you've got a lot of pieces that you need to work with, and you've got a lot of complexity that you'll need to manage in that testing. Even though each piece may be simpler, the potential interactions will increase. And you also require an understanding of how to decompose systems. So if that's not something that you've got a particular amount of experience with, then maybe this is not actually for you. So assuming that you've decided, yes, our problem deserves it and we can do it, then you might end up with something that looks kind of like this naive approach. And in this approach, we've basically got a number of domains, and each domain is responsible for an aggregate of the system. So each domain now has a service, and that service is simple and focused. So you can consider it in isolation. And each service can communicate with other services via RPC, or it can use events produced by other services if you want to reduce coupling. And you can easily build this kind of thing as a kind of proof of concept, because it's not actually that complex. Unfortunately, as your domain size grows, the complexity doesn't stay as manageable. So that kind of proof of concept is misleading. And you might not notice that until you've committed significant effort into your development. The problem with this really comes down to interconnections and managing process. When you look at this diagram, then what you see essentially is that the number of possible interconnections is a triangular number, n times n minus 1 all over 2. So at 6 nodes, that's 15 possible interconnections. At 50 nodes, you're up to 1,225, and at 100, you're up to 4,950. And 100 nodes is not actually an unreasonable number if you have a complicated domain. reasoning about that many potential interactions is actually very hard. In practice, you tend to have that be moderated somewhat because the domains tend to clump together in terms and how they communicate. But still, you're going to have quite a lot of communication potential there. And thinking about that all at once is something that human minds aren't particularly good at. And then you get to the problem of process, and process is a lot harder. In this particular model, each domain needs to know about all of the business processes that its aggregate root is involved with. It not only needs to know how it's involved, but how it interacts with the other domains to make the process work. That leaks implementation details. So suddenly services aren't as clean and maintainable as you might like. Services will start picking up a lot of state for managing process that's not core to their particular purpose. And also becomes really hard to determine where a process is because the state is actually distributed all over the place. That can make it really hard to fix errors, but worse, can actually make it really hard to detect errors because there's no single place you can look at to just verify that everything's okay. And it gets even worse when the process changes because how do you handle existing processes? Do you have to map them into the new state? How can you even do that if the old state's all over the place? Do the services now need to handle things using the old process versus using the new process? And how many services do you need to change whenever that process changes? And then what happens if multiple processes need to change? How do you even build that in concurrent streams of work and then merge it together? And how do you manage the testing and deployment of that? So what you've done is you've not eliminated the complexity of building a monolithic system. What you've done is spread it all over the place, and that's actually worse. So what we really have here is process as a missing concept. An IA domain design assumes that domain entities are the core of the system, but although they're a first-class concern, they're not actually the only concern that we have in this system. How they interact is also a first-class concern. And business cares a lot about process, and they often care about that more than the specifics of any particular domain. And if they care about it, then we should have a way to represent that. So what we need is a way to make complexity manageable, and we can do that if we can separate out business rules from business process. The business process is distinct. It can be altered separately, potentially separately from the business rules. It gives us a single point to determine the state of a process and reduces significantly the complexity of interactions. So in building the system, we also have a number of other requirements. We need to be able to provide data to users. If we've distributed the data all over the place, then we need to provide a consistent view of that data to end users and collate it in some fashion. If you try to do that cross-database, then cross-database queries will cause enormous coupling concerns, but the data in those services is also unlikely to be in formats that necessarily support the kinds of queries that you want to run, and it might be stored in different data storage technologies or on different database servers, which makes collating it quite difficult. We'll also want to accept user input. That's fairly self-explanatory. But we'll also want to be able to interact with external systems. Most large systems want to be able to interact with other systems. We need to do that in a way that avoids coupling. We don't want to be prevented from changing our system due to external system limitations, but also we don't want to prevent external systems from changing because we are coupled to them. So we basically need a way to address these requirements. And the solution we have is essentially that we need to provide simple design patterns for each requirement. These are based on well-understood requirements. They should be familiar in many ways to people who have used tools like Service Bus or Event Store. The patterns that I'm presenting here are basically a synthesis of ideas that my teams got from people like Greg Young and Udi Dahan. So we don't really claim these ideas, it's just we like them for a certain class of problem. So what we start with is we start with a command processor, which is something that owns an aggregate root and is responsible for both the data and also the business rules that apply to that aggregate root. It's conceptually quite simple. We have some kind of channel in which commands come in, and then we send out to another channel events. We have a database that contains state that the domain needs to perform its actions, and that database is not shared with any other component. It may consume commands sequentially or in parallel. That's really an implementation detail that will depend on your particular technology choices. Each command is a request to perform a business action on an aggregate route. These are named in a future tense, and that name is important, and it should have business meaning, so you understand when you have a command exactly what the intent behind it is. Each command mutates the state of an aggregate route and produces events that fully describe that change. Those events are named in the past tense, and they describe something that's happened. And those event names should have business meaning, and that business meaning is kind of critical because that especially if you're doing event sourcing, becomes your book of record. Command processes are not required to honor any request. If the business rules say that an action shouldn't happen, then that action doesn't happen. You may choose to produce an event that indicates a command was rejected. We happen to do this because we require that all commands produce an event as part of our DR system. But that's not actually required. It can just drop it on the floor if you choose. You will need to ensure that all data is saved. If you're using event sourcing, you want to make sure that all the data in your system is captured in events. But otherwise, if your events are transient, then you want to make sure that the domain database captures all that information. Otherwise, it's going to be lost. So the example I'll be using tonight is a driver's license system, and that contains some obvious domains, such as a license. But a license may not be the most important aggregate route in the system. You might have yeah, just like a text. Damn it. Yeah. Oops, wrong one. Where do I go? I'm lost. Yeah, damn it. Go back. Okay. That's better. You may be more concerned with other aggregates such as application and assessment. You can still hear me, can't you? It's not just a monotone. And there's some things that physically may be multiple entities. A person, for instance, may be an applicant, a license holder, or a disqualified driver. And those things might be aggregates or properties of aggregates. You might have things that are multiple aggregates at once. For instance, you can hold one class of license while applying for another. The microservice approach kind of forces you to think about these concepts in a way that a monolithic architecture might not. So this slide again. So users are quite annoying in that they want data that combines information from multiple domains in ways that might not actually be nicely structured for processing. So grid model populators basically compose this information that users want from the events produced by command processors. So they read events in from a channel, they do some processing on it, and they store it into a database. And then they provide some kind of endpoint that data can be queried via. And this is inherently CQRS. So what we have here is that we provide a separate model for each query that the system supports. This denormalizes data structure. And it optimizes the data for each query. So where queries are executed a lot more than updates, that can be a significant performance gain. It also allows query structures to be changed independently. And we can scale this architecture in multiple ways. We can build multiple copies of the read model and balance query load between the copies. We can also use multiple populators for scalability or for more flexible deployment. We can provide separate resources for specific models and scale those independently. And we can also shard some models, but not others. And additionally, we can actually use multiple data stores. So you can use a combination of data store technology if that best fits particular queries. So you could use SQL, you could use Scene, NoSQL, you could use as your table storage or blob storage. And one endpoint can provide queries against multiple data stores. So you can hide all that complexity from your end users. These read models might be exposed via a web endpoint or via custom protocols or WCF if you're feeling particularly evil. But it's key to know that updates are eventually consistent. So basically, you need to make sure that when you design for it, you accept that data can be stale. You cannot assume that the result of sending a command is immediately available. And if you have multiple models, then they may actually not represent the same state all at the same time. Accepting user input is fairly standard. You basically have some kind of user who interacts with a browser or client application. Then they will interact via web API, and that will produce commands to get sent into the system. That generally uses the same endpoint as read model populators. That's not required, but it's generally easiest to do that. And again, that doesn't actually matter from a technical perspective from the rest of the system, whether that's a web endpoint or an API that's provided for another application to use. External integration can be either passive or active, or you might use a combination of both. So passive provides an integration point, allowing a remote system to interact, to call into our system when it chooses. And generally that will send commands into the system, although it may actually be given ownership of a particular domain and send events. Active calls integration points on other systems. So essentially you can have a service that sits there, reads events off the queue, and based on some of its own business logic, makes calls into a remote system, or can also occur as part of processing a command in the service that handles processing particular commands. But the rest of the system sees commands and events. As much as possible, those commands and events should reflect business concepts, not implementation details of the integrated system. This avoids issues when that external system is changed or replaced. But if unavoidable, you should really make it so that it's extremely explicit that those commands and events relate specifically to a particular type of external system. So you go avoid entirely, or you go all in. Examples of integration include things like providing or calling a web API, queues, file uploads, say via FTP file storage or Azure blob storage. Process managers are really the bit that ties it all together. And process managers coordinate business processes in the system. They're essentially a state machine that tracks a process plus the data required to coordinate that process. They react to events produced by command processors in order to transition their state. And they send commands to command processors in order to have them perform business actions. They can also internally generate triggers based on alarms, which are generally time-based. The domain database stores process instances. These record process state as well as the information required to match incoming events to process instances. It's important the information stored is that which is required to determine how the process flows and not used to implement business logic. It should mostly be things like aggregate IDs, alarm times, and similar. We also store serialized commands so that we can reissue them on failure without needing to store all of the component data used to generate them. We generate events to track the state of the process manager. That's optional. Generally, nothing should store those events because they are just internal representations of state machine transfers. But we use this as part of our DR strategy. So externally, based on this diagram, it's quite similar to command processors, except they consume events instead of commands. And they produce commands as well as events. And this pattern should be particularly familiar to people who've used in Service Bus, where it's basically known as a saga. So processes are all about coordination. They're not about business logic. Business logic is the concern of a domain. And if that leaks into processes, it becomes more difficult to maintain both. That's particularly true if you have similar processes, such as an online and in-person application process. They'll generally have a primary domain for which they manage interactions with other domains. And they should have a defined lifecycle after which that process instance terminates. A process without end has to handle every possible case. and that way madness lies. I've worked on a system which ended up being the most complex process the workflow vendor had ever seen, and that's not a compliment. It tends to be an extremely difficult process to manage, to maintain, to work out what's going on, and it can consume significant resources. It's just a nightmare. So processes should also not be resurrected. Subsequent need for process is handled by creating a new process. Because if you try and resurrect a process, trying to fit new state into a resurrected process is problematic. You've got to work out how that new state aligns with wherever that process happened to end up. So making a new process keeps each process simpler. You should also keep them simple and focused. That keeps your complexity manageable. If a concept that you're trying to use doesn't fit into your process manager, then you've probably identified a new process or a new domain. And if you want to have a complex process, then the best way is to chain or compose your process managers so that each remains individually simple, but overall a complex process can be accomplished. So we have a couple of different diagrams that we use to document these processes. We have this one, which is our workflow diagram. This describes the process in terms of its states and the transition between them. This one shows a simple process that creates an assessment and then waits for that assessment to be created and for the outcome of the assessment. If that assessment is approved, then it creates a license. Otherwise, you get an immediate decline. So a waiting state indicates that the process is waiting for the outcome of one of its requests. So this waiting for assessment creation means that the process has sent a command, which is generally not shown on these diagrams, and it's waiting for an event that indicates that a command has been responded to. The retry handles cases where the response is not received in reasonable time. We generally use that for DR, as we only replicate events into our DR environment. This mentions event, but it doesn't actually mention the domains to which they belong, because in the context of this diagram, it's not generally particularly relevant. We're discussing how the process works, and those events should have clear enough names that their meaning is understood outside the domains that they're specifically attached to. This is the complementary diagram that we have that shows the components involved. A circle represents a domain implemented by a command processor, and a cloud represents a process implemented by a process manager. Solid lines represent commands, and dashed or wavy lines represent events. Normally we use wavy lines, but getting those to work in Visio is quite difficult. So you can optionally number the messages that you have to indicate the ordering that you have. This form's good at describing all the actors that are involved in a particular process, but it's really terrible for showing variations to the process, which is why we have the two different types of diagram. So basically, you combine them together to get both workflow and context. This form mostly ends up on whiteboards, whereas the workflow tends to be captured in documentation and taken to the business for their validation. So in this example, we might alter the process in future to always give a provisional license on application, to change its state to withdraw or full license on completion of the application process. In that case, we'd only have to modify the license domain and the assessment process. Or you can have other potential alterations, including adding a written test prior to the assessment being conducted, or creation of multiple license types. So once the license is created, this process ends. Other things can happen to licenses, such as renewal and revocation due to traffic offences, would be handled by different processes. Yes, Cam, I'll definitely make sure I put more wavy lines in future for you. So obviously, processes will have to change over time. And in many respects, business process is going to change more than specific business roles. So what we then have the problem that mapping an existing process instance to a new process is quite hard. If your new process does A, then B, but the old process did B, then A, then how do you map odd processes that have done B but not A? Do you have to have specific logic to handle that particular case? Because that kind of logic gets very complex and it's risky and expensive. So just don't do that. What you do is you take the existing process manager and you just adjust it so that it no longer creates new instances of processes, but it continues running with the existing instances it already has. And new processes are created in the new process manager that implements the new process. So essentially, you can then run down all the existing instances in the existing process manager. And when all of those instances have terminated, then you can retire it. So ideally, you may not need to change any command processes if your business rules are not changed. However, you're generally going to expect that a few process managers will need to be adjusted in some fashion if you're modifying the process, even if only in a trivial fashion. But situations involving modifications to all of your command processes are exceedingly rare, especially as your system gets larger. So essentially, you're encapsulating almost all of your change to a business process into a specific process manager. And that's a significant saving in complexity. And Cam will do my work if I tell him to. So, obviously, when it comes to actually building this system, then you've got a choice of whether you decide to build your microservices platform yourself, or whether you decide to use an existing platform. And there are a lot of existing options that can help you in Service Bus and Event Store, a couple of ones that I have some familiarity with. Or you could try custom build. Custom build is non-trivial. For instance, our platform, I've spent about 18 months as the primary developer on it. Plus some involvement from the rest of our team, but we needed to do specific things on Azure that the existing options didn't work particularly well with. However, you do need to understand that if you're building your own platform, that it will not have the same performance, it will not have the same kind of tooling, and it will not have the kind of support you'll get with a third-party option. So in summary, you need to justify your choices and confirm that you actually have the capability to deliver them. This is an area where everybody loves the microservices term, but you really do need to justify it because it has a lot of complexity involved. And if your problem doesn't justify that, or if you don't have the capacity to deliver it, then you're going to spend a lot of money and not produce a working system. You'll need to separate your business rules and your business process so that you need to understand the clear distinction between what is the business rule and what is the process that manages the invocation of your business rules. And there are a couple of core patterns. There's command processes, there's process managers, and there's read model populators, which really are the core of this system. So that's basically my presentation. I'll take a few questions in a second, but first, a shameless plug for Dee Dee Deep Earth, which is on the 29th of August. Submissions and registration are now open. So if you've got the burning need to come over to Western Australia and say things in front of people, then please, submit now.
Awesome.
So,
should also plug DDD Melbourne while you're at it.
I should. I don't know when that's on. I think it's, what, the 8th of August?
If you're in Melbourne. The talk submissions are on at the moment. dddmelbourne.com, I believe, is the address. So yeah,
yeah. Go there, vote for me to do this presentation again there. Cool. So
all right, let's have a look at the Q&A, shall we? And good first question, or in fact the only question at the moment, which is, can we hear Colin grunt, gulp, and say yeoman?
No.
All right. Let's see. Okay, so any testing patterns you find useful?
Well, we obviously do a lot of unit testing of our individual domains. We have a couple of different other levels of testing. We have what we call QA tests, and these basically on each environment that we deploy, these are basically health checks that check all the services that we expect are deployed, and that they are not recycling in Azure. And also we do things like check that they haven't had any critical errors written into our logging system within the last 10 minutes or so. And those tests run every 15 minutes or so. I can't remember the exact frequency. So we have health checks that that we implement. They're basically just running in TeamCity. We also have a bunch of UIA tests that pull up our terminal and shove information at it and mostly verify the happy cases in our UX. I know very little about those because I stay far, far away from pixels. But we have a fair few hundred of those, and those are basically verified that our terminal remains operational. Plus, obviously, we have a number of testers assigned to our project, 4 or 5, depending on the day, who are, and we have to go through testing. So yeah, that's fairly traditional multi-level testing.
All right, Colin, can we redo your presentation in WPF?
No, I would lose too much blood cutting myself on the XAML.
Well, Shifty's actually suggesting Prism. You could use that. That would make it easier.
Yeah, he would. Some of these other questions.
All right, so let's hit some of these other ones. You got them? Yep.
Yeah, how small are the production microservices? Generally, each command processor handles a single domain, so a single aggregate root, such as an application or such. And then we have processors for many things, each of which tend to be specific. So we'll have a separate install versus online application process, for instance. Then we have an assessment process that's separate, and we have an assessment domain as each. So each individual aggregate tends to be quite small, although some of them will have, depending on the nature of them, will have 60 odd events come out of them. Those are the larger ones, but each is generally a fairly small contained piece of logic. It's basically when you can't break the thing up any further and actually have any value, that tends to be our boundary. It's kind of difficult to say precisely what the boundary should be. As a rule, it's kind of, you've got to look at the problem in the context, rather than just say, here's the hard and fast rule, this is where you chop it, because each case is different. It generally tends to be things like what would be the ubiquitous language of the business, what concepts does business understand and want dealt with, and then the processes are things like, how would we manage this concept? I hope that answers that particular question. So yeah, we have, last I checked, over 70 services deploying. That includes our command processors, our process managers, and the endpoints that we have for external interaction. So yeah, we've got quite a few, and is still growing, which is why automated deployment is so essential. I have had no experience or comparison doing any of this in Erlang. Erlang would be doing a lot of stuff concurrently inside a single process, as I understand it. We're actually deploying each of these separately to a individual Azure worker role. They're extra small, so they're fairly cheap. The startup delay is a little annoying, however, but yeah, they tend to be a single thread of execution on a extra small shared VM, essentially. Well, the VM itself is not shared, but it's got a shared CPU. Whereas potentially, if you're doing it in Erlang, you would have multiple concurrent threads of execution, but they'd all be inside the same process, which would be quite a different model. That's not the model we've chosen for a variety of reasons, mostly because, although I haven't really gone into it much, our system is based on event sourcing. Let's see, what else? Synthetic transactions. Well, I'm not sure I'd really call them transactions. We have various retry mechanisms and such built in. I don't really have time, given we're already over, to discuss precisely how, but essentially the process managers are responsible for detecting that something hasn't happened in a particular time and then just retrying it. We used to have that be quite short. It was 10, 15 minutes. And then we found in certain failure cases, particularly DR or when the system was very heavily loaded, that nothing would get processed in that time and it would just resend everything and completely flood the system and fall over, which was slightly unpleasant. So we basically bumped that delay up significantly. But yeah, it is essentially just a fairly simple state machine. And we have internally, we have classes that implement how each state should transition to indicate. So when it determines what state you're in, it loads in the appropriate process state handler class, and that implements all the logic for how you transition out of that state, a lot of which are not supported because we operate on a model of fail fast, where a service, in the event of certain errors, will just stop dead until a human comes along and fixes it, which does tend to horrify people. But we've chosen to basically work. Why exactly did we choose it? Note to self, think of sentence ending before starting it. Essentially, we want to prioritize being reliable, being correct over being available. Yeah, certainly our custom infrastructure isn't nearly as rich as something like in Service Bus or Event Store or the other existing platforms. We have these hubs that are based on web apps, and we poll against them and such, which are our message distribution mechanisms. And our throughput on those is sufficient for our particular application because we can partition by geographic region, so we don't actually need to scale ridiculously. Our system is very much built to our requirements. Let's see. Any other questions?
The question about Service Fabric. So the new Azure Service Fabric and your thoughts on that?
My thoughts on that, it's something I need to look into once we get past our current stage, which is pushing to get something deployed. We're kind of in the final stages of our project at the moment. It's going quite well, but we're kind of at the point where we've stopped any kind of speculative stuff and we're just building the system out for our release, and we'll look at that kind of thing once we've actually gone live with this new system.
Cool. All right. Well, we will call that a wrap. Again, thank you very much, Colin, for that. That was very cool. So I'm sure the chat channel is going to, in a few seconds, do the clap, 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 thank you very much thing, which we'll have to figure out. How do we do applause when you're all virtual? So for reference for tomorrow night, we've got 3 talks. Let me just remind myself what's going on again. So 8 o'clock, we've got Aaron Powell doing Yeoman Grump Gulp Bauer Node something else, all about web stuff. We've got Mitch Denny doing Azure Event Hubs in the 8:45 talk, and then 9:30 Kanye is going to be with us doing Reactive UI, which will be awesome. So we've got to give Kanye a bit of love, or Brendan Forster, depending on which one of them shows up. You never see Forster and Kanye in the same room if you've never noticed that. And
Australian
one of the other things that one of the other things that I'd like to do is if you've got any feedback or thoughts about how we could improve how the session's going or anything like that as we go through the week, session by session, it'd be great if we could just get some feedback. So just drop a tweet to ANZ Coders or myself at rbanks54 or an email or whatever else works for you, or even just drop something in the chat channel at the moment, which would be great. And we will see you tomorrow night. Thank you very much for showing up. Go and watch Game of Thrones if you haven't seen it already. That's what I'm going to be doing now. Got to catch up. And we are done. Thank you very much. See you guys later. And hang up.